Alright guys, so anybody need a copy of that sheet I gave out last time about fractions? Fracciones. Sheet I gave out last time about fractions. What? Alright. I love you guys. When I say shit, listen to it. It makes it easier to know what I'm saying. Can I go? Yeah. Anybody else need a copy of the fraction worksheet that I handed out last time? So we're going to go over this worksheet from last time. So get that bad boy out. Any questions from homework stuff maybe or anything before I... Last time. So that would have been Thursday. Okay. Well, you got it, right? I just gave you one. Yes, okay. What's up? Anybody else need a copy of that fraction worksheet from last time? Need a copy of that? Anybody? Need a copy of that fraction worksheet? Connie, do you need a copy? Okay. I have to ask everybody individually. Right. What's happening? Holy shit. I love you guys so much. Anybody need a copy?
I think I do.
Wait, here.
Hold on.
That was sort of joking.
Hold back.
You can get a copy, just, you know.
Yeah.
So it's our fault that you suck at life?
Yes.
Alright. My patience is worn thin this semester. I do want to apologize. I have issues with some of my other classes, students who aren't used to doing homework, and they're not used to tests that aren't the exact same as the practice tests they give out, stuff like that. So yeah, it's college. Get used to it. Suck it up. But anyway, so I don't mean to take it out on you guys, but you know, listen. It helps out. Alright guys. I don't know if anybody tried this out yet. Can somebody turn off, experiment with those lights back there? See what's good. Anybody? Thank you. That's a good one. That's a good one. That's pretty good, right? Alright. Alright guys. So we looked at this idea of mixed fractions, improper fractions. I showed you a few different ways to look at it, some ways you had never seen before. Who remembers how this kind of thing works? How do I change this back? And what does an improper fraction mean? What does it mean to be an improper fraction? That means you wear the wrong clothes when you go out to a white tie event? Yes. Say again? 3 numbers? No, I don't understand.
The denominator is lower than the...
Yes, the numerator is larger than the denominator. Alright. So we're going to try to convert this back. Guys, so it kind of makes sense that if the numerator and the denominator were the same, what would that actually be? 1. If it's 17 over 17, that's 1. So if the top is larger, that means it's a whole number plus some extra stuff. Hence the invention of mixed numbers. A whole part and a fraction part. I like it. So how do you convert this back to improper?
8 times 1.
Yeah. 8 times 1 plus 1. So it'll be 8 times 1 plus 1 over 8 equals 9 over 8. Okay, cool. I like it. And it sounded like most of you guys knew that. I just showed you some weird other stuff, other ways to look at why it works the way it does. So number 2, what would happen there? Yeah, so it'll be 15 plus 2. I like it. And see why this makes sense. If it was 15 over 3, that's just a pure what? 15 over 3 is?
I keep saying that everywhere I go now. I like it.
5. Thank you. So 17 over 3 is a little bit more than 5. 5 and 2/3. It's a big example. I like it. What's happening?
What you say?
I like it. I like it.
Oh, okay.
You know you're saying it, huh?
No, I don't. Alright, guys. So what about this guy here? Yeah. So 6 times 3 is 18 plus 5? 23 over 6. Kick ass. Trying to be a 3. So just to show you. So what you do is you do 6 times 3 plus 5 over 6. And remember, I showed you this real quick, just to remind you guys. If I look at, and score, that comes out to be 18 and 5 is 23 6. If I look at 3 and 5 6, 3 is over what right now? 1. So this is a little bit ahead, but I think we're there now. How do I make that the same as this? Multiply by 6. In fact, it's always going to be 1, because there's always going to be a whole number in front. I'm always going to multiply by whatever that is. So that's where 6 times 3 comes from. And then I'm going to add 5. So that's why the shortcut, it's just a shortcut, but that's why it works. I like it.
You can do it with any fraction.
Any mixed number.
But that's what I meant, yeah.
Yes. What? So what about this guy here? 16 times 2 is plus 3? 35 over 16. Cool. I always have somebody that tells me this equals 35. And I'm like, holy crap. You got 2 and 3/16 gallons in your car. I got 35 gallons in my car. My car's busting, you know. No, I don't think that's how it works. Right? It's got to be over what was there in the first place. Yeah. I know some of you guys, this is old, this is like, oh my god, why are we talking about this? And some of you guys are like, holy shit, I forgot all about this.
Yeah.
So, yeah, if you're in the first department, just sit there and wait.
Yeah.
Yeah, basically. Oh, here comes Steve. Was that Dee's entrance music? Is that Alright guys, so what's interesting about 10 over 4? Anything interesting about that at all?
It's an improper fraction.
You can reduce it. So what do you get when you reduce that?
2/5.
Careful.
5.
Divide that by 2, you get 5. Divide that by 2, you get 2. So you can either reduce first or reduce last. I'm going to reduce first, make my number smaller. Yeah. Oh, you're good. Alright. So now, how do I make this into a mixed number? Yeah, 2 goes into 5. 2 times with 1 left over. I love the way we've said it forever is the way we actually write it. The 1 is left over the 2. I like it. You guys good? Somebody look concerned about something? Yes. Alright. Let me come back to this. So the first step is cool, right? Making this 5 over 2. Alright, so what we're really doing is we're doing what it says to do. We're dividing 5 by 2 because that's what that says to do. 2 goes into 5 twice with 1 left over. 2.5. Now some of you guys might remember the other way to do this is to say, okay, 5 over 2. Well, what does 2 go into? Not 5, it goes into 4. So can't I write this?
4 plus 1.
That's amazing, right? Good job, Jeff. 5 is 4 plus 1. Yay, Jeff. But then what's 4 divided by 2? 2. What's 1 divided by 2? 1 over 2. That's really what's going on in the background. That's why the remainder means what it does. It's like the excess. It's the stuff that 2 doesn't go into, so it's still being divided by 2. I just can't complete it. So I got a whole number part that 2 goes into, and then the leftover that 2 does not go into. All right, how are we doing there? Is that? And again, you might never have looked at it that way before, but it's really good to be able to know how to look at things several different ways. All right. Unless it was the debate last night, I only want to look at that barely at all. Sorry to bring that up. If you watch South Park, it makes you feel a little bit better. But... All right, what about this guy then? 16 goes... And in fact, can you... What would be the excess? How much above 16 is this? How much above 16 is this? 9. We got the answer then. There's a whole 16 in there, and then there's 9 16ths. Now, if that's too much to do all at once, you can still do, like we always do, 16 goes into 25 once with 9 left over. 1 and 9 16ths. Is that decent? But you have several different ways to look at it. Pick the way that makes the most sense. Yes, ma'am.
Can you do 5 over 4 and down by 2? Reduction.
Where are we at? Sorry. Oh, okay. All right. If what you said is true, then 1/2 should equal 1/4. Is 1/2 equal to 1/4? No. So you cannot square the top and bottom and keep it the same. What's the only 2 things you can do to the top and bottom of a fraction legally? Multiply or divide. That's it. That's the only thing that maintains the idea of the fraction. Are we cool with that? So I can't say 1 over 2 is equal to 1 squared over 2 squared, because 1/2 does not equal 1/4. Thank God. I got half a tank of gas. It's a quarter of a, what's that, 16th of a tank of gas? Oh, shit. Yeah. It's a very bad situation. All right. So this guy, 3 almost goes into 25 directly. Yeah, there's 8 3s in 25 with 1 left over. And how do you check yourself? 3 times 8 is plus 1. Check. Because going the other way is easy. So that's how you can do a real quick check and make sure it actually came out right. I like it. And this is almost the same idea.
4 times.
Yeah, 4 goes into 17 4 times with? 4 times 4 is 16 plus 1 is 17. Yay!
But when you write it, you don't want us to write it like that, right?
What do you mean? Of course I want you to write like that. What other way would there
Like
be?
the solve one. Like when you say, show your work, right?
Oh!
Just like,
This is one of those situations where if you understand the process, there's no real work to show. Unless you want to do it this way.
that's one.
You should be able to handle 17 divided by 4 in your head. So you could definitely argue you don't need to show work, and I agree with you. So guess where this would show up on a test, on the part of the test where you're not allowed to use calculator. That's right. Careful with the word calculator, it makes you sound drunk. You're not careful. You're going to have a calculator. All right.
What about calculator?
So this is the idea of simplifying, right? Reducing to lowest terms. So lowest terms just means that there's nothing left over that will go into both the top and bottom. So what can you divide the top by? And the bottom. You have to be able to do both the top and the bottom of the same number. What's happening? What goes into 6 and goes into 32? 2. I like it. Yes. So divide by 2, divide by 2. 6 divided by 2 is 3. 32 divided by 2 is 16. So if in your calculator, if you type 6 divided by 32, the decimal that shows up would be the same decimal when you type 3 divided by 16. They do represent the exact same number.
Just different language.
Comes out to the same decimal, yeah. I like it. How we doing? Which is kind of silly. If you think, is 10 divided by 2 different from 30 divided by 6? They're both what? What's 10 divided by 2 and what's 30 divided by 6?
Good.
What's 30 divided by 6?
5.
5. Why are you looking at me like that? You're all like, what's the trick? No, it's 5. And what's 10 divided by 2? 5. So 10 over 2 is the same thing as 30 divided by 6. And it's because what did I do to the top? Multiply by 3. And the bottom I multiply by 3. So what's the point I'm trying to make? If you do the same thing to the top and bottom of a fraction, it's guaranteed to remain the same number. And there's a real silly thing about it. What did I actually multiply? 3 over 3. Well, what's 3 over 3? 1. I multiplied by 1. So of course math is like, whatever, dude. You didn't change the freaking number. Probably, all right, math. Sometimes I want it to look like 30 over 6 if I'm trying to add it to 7 over 6 or something. I need it to look like that for a minute. You're like, all right, math, calm down, man. All right, where did I... Oh, this here. Yes, sir. Oh, here, I'll give you one. Let me make it quicker. We're just working on... I like that. It's kind of cool. This here. I think we just got down to this section. All right, guys. What about this here? Yeah, 7 goes into both. So little numbers like that, you desperately have to know what goes into both. You have to know your times tables to be able to do this stuff backwards. I'll show you something. I'm going to be kind of silly here. They're both even, so I can divide by 2, right?
Yeah.
I know, but I said off the top. So divide by 2, I get 9 over 12. Is there still something that works?
Yeah.
Yes. So this is perfectly fine. If you don't notice anything except one thing, do that, because then the numbers get smaller, it's easier to work with. So immediately cut it down, but just realize you might not be done after one step. Now I can divide by 3. Divide by 3, I get 3 over 4. So if I would have divided by 6 to begin with, I would have gotten there faster, but this is not necessarily a race, right? You just do what you see first. This one's very straightforward, hopefully. The problem is I get people that tell me the answer is 6.
Yeah.
That makes no sense. Yeah, 1 over 6. 5 divided by 5 is 1. 30 divided by 5 is 6. I like it. So be careful. 5/30 can't be 6. It's way less than 1.
So
Yes, sir.
would the answer be incorrect if you add 6 instead of 1?
So if your boss said, how many thousands of dollars will we make next week? And you say, I predict we make $6,000. And you actually end up making 1/6 of $1,000. Is there a difference? Yeah, there's a huge difference. And the difference might be you're out in the street, you're without a job. Right? So 6 and 1/6 are completely different answers. Same thing as 6 and -6. They're even more different. They're on opposite sides of the number line. So I often have students that say, well, I got the 5 part, but you didn't have the negative. That's the difference between making money or losing money. And that's even more. At least you, in your situation, you're still making money. If I'm like, yeah, boss, 5, and it's -5, I'm screwed. I'm out. You know, does that make sense? I mean, so -5 is not the same as 5. 1 over 6 is not the same as 6. They're completely different. So yes, you would lose points on that. Cool. I don't know why I didn't have examples of this last one. But we did a lot of these last time. Remember this here?
Yeah.
You could do this if you want to. Break them all up and then kill the common kill, die. You don't have to be all, violent like that if you don't. All right. Is everybody cool with that one? Anybody want to see an example of that one?
sure.
All right, here we go. No,
Whatever.
so what about this here?
Is that 30?
I ordered it like, the wrong thing, but we just got it.
What, like it? Nice and gross. So you look up and down, and you look diagonally. Can anything cancel between numbers?
Yeah.
25 and 30.
Yeah, what goes into 25 and 30? 5. 25 divided by 5 is 5.
6.
6,
30 divided by 5 is 6. I like it. What about this way?
4, and 7.
7 goes in, so 20 divided by 7 is 4.
And then that one,
49 divided by 7 is 7. And nothing else goes in anywhere, right? So what do you end up with?
34.
Who to what?
34?
6 times 4?
24.
24. 7 times 5?
35.
35. Why do you not waste any time trying to reduce this? Because you already know that no parts have any common stuff, so the answer's not going to have any common stuff. Don't waste time. That's why it's better to look at it before you combine them. So you got smaller numbers. I like it. Question mark? What's up? We're good? Well, that's a new way to do it. Question mark, teacher? Exclamation mark, student? Alright. I think we got into this idea here, didn't we, about giving it what it's missing? Did we talk about that yet?
Yeah.
No, yes, I'm getting some no's and yeses. Okay, let's talk about that by itself. First off. Jen, can you try that? So it's if it falls, it's my fault, don't worry. Is it alright? Oh, it's gonna fall now, watch. Is that good?
Yeah.
Alright. Okay. So if I had 3/4, let's start off nice, plus 1/8. Now number 1 is, the answer is not 4 over 12. What would the person be doing if it got 4 over 12?
Adding both of them?
Yeah. I don't see any 12s. How did that person get 4 of them? I see so many 4ths and so many 8ths. So there are no like terms currently. I want you to realize, if you realize that, fractions are easier to deal with. You have to make them like terms and then you can combine them. So what's the LCD going to be? No. The only time the LCD is the product of the two numbers is if the two numbers have nothing in common.
16.
I can make 4 become... So 8's the LCD. I don't have to change both of them. I only have to change one of them. So look for that first. Only change both of them. You're like, I don't see how to change one of them. Shit, I got to change both of them. Okay. So what do you multiply this by? To make it become over 8?
2.
So to make it legal, you do top and bottom. So I'm giving it what it's missing. Right? Because 8 is 4 times 2. This only had a 4, so I gave it the extra 2. So now I get, yes, 6/8 plus 1/8 is... What's that? 7/8, Jim.
Or I remember.
It sounded like somebody was yawning part of a song. Was it all the single ladies? That was horrible. This is why I teach me. Oh, there we go. We got dancing on. Okay. So what if I have to change... Oh, a real quick example of what I just said a second ago. If I had 2/5 plus 3/7, do these have anything in common?
No.
No. So then that's the LCD would just be 7 times 5. Because he's missing 7. And he's missing 5. I like it.
Gotta go.
What's that?
Gotta go.
Okay.
Alright.
So you get 14 plus...
$15.
15 over
35.
35. So I know sometimes I ask really easy questions, but that's just to make sure you're actually looking this direction. For a minute I thought everybody loved me. All right, so let's look at one that's a little more disgusting, because these two were semi-easy ones. You always look, please, dear God, let me make one of them into the other one. That's beautiful. Or let them be just relatively prime, is what it's called. They have nothing in common, then I just give each one the other guy. But then you get a problem like this. What you got, Jeff? I don't know, man. Sure. I like it. So here's where this method becomes really nice. You could just count by 24s or count by 20s, and I've seen a few of you guys do that method. But the method I'm about to show you will work even when you eventually get to the point where you have variables down here, not just numbers. Oh shit, then you have to look at it the way I'm about to show you. What's the largest number that these have in common? 4. 24 is 4 times 6. 20 is 4 times 5. Now what's beautiful about this is I can see exactly who's missing what.
Yeah.
So what's he missing that he's got?
5.
5. Yeah, give me 5. All right. And what's he missing that he's got? 6. So now they both have 4, 5, 6 on the bottom. Is that cool?
Yeah.
Let that be nice. The whole purpose is to multiply them up so that they both meet somewhere. If you break them down and see what they already have, it's easier to figure out what they need to get to meet somewhere. He needed a 5, he needed a 6, now they both meet at this number. What is 4 times 5 times 6? 20 times 6.
29. Yeah, 26.
What is happening? What is 20 times 6? What's 2 times 6?
Well,
Now add a 0 onto it. What's 20? Alright. So what do I get over 120? What do I get? I get 55 minus 6 over 120. Because now they're both 120 on the bottom. Is that? Since you made them like terms, you're allowed to put them together. 55 minus 6 is
49.
49. And does anything go into both of these? Hell, 49 7s, and 7 does not go into 120. Okay. Let's do another one. Oh, what you got, Jeff? I don't know, man. Oh, no, Jeff. Sure. Ooh, that looks yummy. I like it. So where you start is, what is the largest number that they both share? 8. I like it. So 40 is 8 times 5. 64 is 8 times 8. What's this first guy missing that he's got? Another 8. He's only got 1 8. I only got 1 8. He's got 2 8s. All right. He's got 5. I don't have any 5. All right.
Slow down.
So this guy's missing 5. Now they both have the same denominator. 8 times 5 is 40. 40 times 8 is... What's 4 times 8?
36.
32. Add a 0 on. 320. So this will be over 320. 3 times 8 is... Let me do it like this. 24. 7 times 5 is 35. I like it. 24 plus 35. 59 over 320. Alright. So that's Personally, that's my favorite method, and I also think it's a good teaching method because, like I said, when you get to harder fractions, where the fractions are made of variables and variable expressions, this is the only method you have. So the more you get familiar with it now, the easier that's going to be when you get to it. So take a minute and do these three. I'm sure some of you guys have already done them, but just if you haven't, do these three at the bottom of that paper. Oops, sorry, you're all attached. So right here, this says 5 over 7 plus 3 over 14. That's right. So what do you got to do? What are you going to make the bottom become? It's the LCD. What can you make both bottoms become? What is that 7 missing to become 14? Like you just said. No. 7 times what is 14? 2. So if you multiply the top and the bottom by 2, you can get... Oh, okay. You're right, there's bigger. So like you said, he's missing a times 2 to become 14, right? So you can multiply times 2 on the top and the bottom. 2 times 5, 10. 2 times 7, 14. And what's 10 14s plus 3 14s?